Hey everyone, welcome back to the channel. Today, we're diving into the fascinating world of a powerful programming concept, recursive functions, learning how to create a recursive function, and explore recursive math functions. Let's get started. First, we discuss the concept of recursive functions. Recursive functions are functions that invoke themselves during execution. They tackle complex problems by dividing them into smaller, similar subproblems. With each recursive call, the problem simplifies until it reaches a base case. Defining a clear base case is crucial to avoid infinite recursion. The given program demonstrates recursion through a simple countdown function. It starts with the function countdown, which prints the current count and then calls itself recursively with a decremented value until it reaches 0. When countdown 2 is called, the function prints 2 and then calls itself with count equals 1. In the next recursive step, countdown 1 prints 1 and calls itself again with count equals 0. Finally, when countdown 0 is reached, the base case is triggered and go is printed instead of making another recursive call. This prevents infinite recursion and properly ends the countdown. This sequence effectively demonstrates how recursive functions break a problem into smaller subproblems until they reach a stopping condition, the base case. Now that we've learned about recursive functions, let's put your skills to the test. Try answering a few quick questions to check your understanding. Take a moment to think and drop your answers in the comments for me to review. Here's your first challenge. If the script calls countdown 5, how many times will the function be executed? Think through each recursive step carefully, drop your answer in the comments, and let's see who gets it right. Here's another one for you. If the script calls countdown 0, how many times will the function be executed? Take a moment to think about it and share your answer in the comments below. Let's see who's got this figured out. Take a moment to evaluate your answer and see how well it matches the concepts we've covered. Drop a comment if you think it's correct and let us know how confident you feel about your understanding of the topic. Now let's dive into creating your own recursive function. First, you need to define the base case. This is the condition that stops the recursion, returning a value without triggering any more function calls. Next, you'll add the recursive case, which is where the function calls itself with a smaller or simpler input, gradually moving toward the base case. Finally, it's important to combine both, ensuring a smooth transition from the recursive case to the base case. This prevents infinite recursion and ensures your function works as expected. In this example program, we define a recursive function to calculate the factorial of a number n. First, the base case is established, where if n is 0 or 1, the factorial is set to 1, ensuring the recursion stops. In the second step, the recursive case is added, where the function multiplies n by the result of n fact, gradually reducing n until it reaches the base case. The program first correctly outputs and then calculates by recursively multiplying the numbers down to 1. This demonstrates how recursion simplifies complex problems by breaking them into smaller subproblems, eventually reaching the base case to complete the calculation. Now it's your turn to test your skills in creating recursive functions. Think through each question carefully and then share your answers in the comments below for me to check. Let's see how well you've grasped this concept. Here's your first challenge. A recursive function that counts up from any negative number to 0. Would the base case be when n equals 0? Think carefully and drop your answer in the comments below. Let's see who gets it right. Here's your second question. Can a recursive function have two base cases? Take a moment to think and then drop your answer in the comments below. Let's see who's on point. Take a moment to carefully review your answer. Does it align with the concepts we've discussed? Drop your response in the comments below and let us know how confident you are in your understanding. Next, we move to the concept of recursive math functions. Recursive functions are powerful tools for solving mathematical problems that follow repetitive patterns or processes. A great example is the Fibonacci sequence, where each number is the sum of the two preceding numbers, starting with 0 and 1. Using recursion, this problem can be broken down into smaller, more manageable subproblems, making the calculations much easier to understand. By defining the sequence in terms of its previous values, recursion allows for a simple yet efficient approach to compute each number in the sequence, streamlining complex mathematical problems into more intuitive steps. This program generates the Fibonacci sequence step by step. It begins by defining the function Fibonacci v1, v2, run count, where v1 and v2 represent the current pair of numbers in the sequence, and run count is the number of steps to compute. The program first prints out the sum of v1 and v2, showing how the Fibonacci numbers are formed. The base case checks if run count is less than or equal to 1, in which case the function exits without making further calls. Otherwise, the recursive case calls the function again with v2 as the first value and v1 plus v2 as the second value, effectively computing the next Fibonacci number and reducing the step count. The program prompts the user to input how many steps of the Fibonacci sequence they want to see and prints each step in the sequence, starting from 0 plus 1 equals to 1. The output shows how each Fibonacci number is formed by adding the previous two numbers, such as 34 plus 55 equals to 89. This program calculates the greatest common divisor of two numbers using recursion. The function GCD n1, n2 first checks if the two numbers are equal, which serves as the base case. If n1 equals n2, the GCD is simply the value of n1 or n2. If the numbers are not equal, the function proceeds with the recursive case, where it calls itself with the difference between the two numbers, reducing the problem size step by step. If n1 is smaller than n2, the function subtracts n1 from n2. Otherwise, it subtracts n2 from n1. The program prompts the user to input two positive numbers and checks that they are greater than 0. If both numbers are valid, the program calculates and prints the GCD. For example, when the user inputs 12 and 8, the program outputs 4, which is the greatest common divisor of the two numbers. This program efficiently finds the greatest common divisor using recursion by repeatedly breaking the problem into smaller subproblems. This program illustrates the recursion depth limit in Python and what happens when it is exceeded. The function recfunc n is designed to call itself recursively, decreasing n by 1 in each call until it reaches the base case n equals to 0. At that point, the function stops calling itself and returns 1. However, Python has a built-in recursion depth limit, typically 1000 calls, meaning that if a user inputs a large number like 1000, the function will attempt to call itself 1000 times before reaching the base case. Since this exceeds Python's maximum recursion depth, the program raises a recursion error. The error traceback shows the repeated function calls leading to the stack overflow. This example highlights the importance of considering recursion depth when designing recursive functions and using alternative approaches, like iteration, when necessary to avoid exceeding system limits. Now that you've grasped the concept of recursive math functions, it's time to put your knowledge to the test with some practice questions. Take your time to think through each question and please share your answers in the comments below. Here's a challenge for you. How many recursive calls does the function make when calculating GCD 12.8? Think through the recursive process carefully and drop your answer in the comments below. Let's see who gets it right. Here's your next challenge. How many recursive calls are made when computing GCD 5.3? Analyze the function steps and share your answer in the comments below. Let's see who figures it out. Take a moment to review your answers and compare them with the concepts you've studied. Share in the comments how many you got right and how confident you feel about your understanding of the material. In conclusion, recursion is a powerful yet elegant concept that helps solve complex problems by breaking them into smaller, manageable subproblems. From understanding the fundamentals of recursive functions to exploring math-based recursion like factorial, Fibonacci, and greatest common divisor, we've seen how recursion simplifies problem solving while also posing challenges, such as recursion depth limits. Along the way, we tackled thought-provoking questions to reinforce these concepts. Keep practicing, experiment with different recursive problems. If you enjoyed this tutorial, please like, comment, and subscribe to our channel. Thanks for watching.